Thank you. Good morning, dear colleagues. This area of pre-tension, pre-stress structures is quite complicated. Not everyone has to deal with it daily. That is why I won't go into too much detail. You can view this copy, your own personal copy of the presentation to think about some details. But again, how can we work? We can use pre-tension, pre-stress, and post-tensioning. And there are various types of systems, bonded systems, unbonded systems. And in SOFiSTiK, you can set any type of reinforcement. So in order to fit into the time allocated for my presentation, I will speak mostly about post-tensioning. So here you see three options, and in our work, we will use wire rope reinforcement according to GOST. And now let's go to the theoretical part, the tests, settings, and verifications, and so on. So first of all, we create a system of post-tensioning, and SOFiSTiK suggests six systems of world-class companies with very good brand names. But you can create your own drop-down list with your settings, with your companies, with your subcontractors. And so you can use your customized data. And it's not possible to make a mistake here, and all of these results will retain, and you will be able to use them further. The system is highly adjustable. Each user in SOFiSTiK can manage and can adjust the output sections and representation of data. So you can elongation and volumes and everything useful. Here is the graph of the loss and tensioning. And this one, verification of forces and losses. And here we compared to manual calculations, and the difference between manual calculations and SOFiSTiK calculation is less than 1%. So it's very accurate and can be highly trusted. And here, to verify the results, we use very simple examples for ropes in SOFiSTiK and manual calculation on the right-hand side, and the results are highly accurate. You can use various options for calculating different parameters. Here we can define the elongation of the wire ropes and volume. We just use the geometrical area. And here, relaxation of reinforcement and shrinkage and creep, everything can be taken into account. And this CSM module is very crucial. You can if you use this module, you can calculate the difference between pre-tensioning and post-tensioning. And so construction stage sequence is very important, and time effects. Secondary hyperstatic, second-order parasitic effects, you can take them into account. It's a very accurate calculation, and I would like to thank the developers because it saves a lot of time for engineers. And now some theory and two very easy questions you can take a look at them in more detail after the presentation. Here you can see hyperstatic moments, and you can review it later. But now let's go to the practical part. So why Revit? In our company, we want to work in a unified environment, on a unified platform. That is why we customize Revit. We set it up for our needs. So SOFiSTiK has a lot of options for setting up wire rope reinforcement, but some ropes cannot be copied to other floors, to other stories, and if ropes are used at the same time in slabs and in beams, we need to assign numbers, some things manually, and it's not very convenient. That is why we use some tasks in Revit and some in SOFiSTiK. So we have families, wire ropes families in Revit, and we apply Russian GOST norms. So here everything is clear, and we export the model to SOFiSTiK. And after that, we use the user interface that we developed as an add-on to Revit, and we adjust the model. And then I'll show you, now I'm showing you, I'm showing a short workflow of how we work with this. And so it can be a parking structure. We select a family for beams, materials, bonded systems, for instance, 9 wire ropes in one bundle. And then we start defining the layout. And you see the points, the fixture points. And we also can take formwork into account. And then we select the placement of additional elements. And here we see the ants that on different types of areas. And here we copy. We use SOFi+, setting up. And for slabs, we use another GOST. Monostrands, non-bonded quantity and length, and we define which ends are which. At the ends, we set up the type of layout. Quantity, again, copying everything. And after that, we see the model. First of all, the slab model, we set up material properties and sections and dimensions, and we check for correctness, nor code check, and geometry. And we see that we don't see high strength reinforcement while we don't have the ropes. After that, we use groups, although it can be done at the very beginning, then tangent export. SOFiSTiK WPS works with the codes. And here we see that here we have tendons, and geometry is the same, and high strength steel is used here, and we automate routine operations. We see that everything has been transferred, bonded, unbonded systems, materials, everything is correct. And we start the calculation the calculation runs, and we see combinations, and after that, separately, we can see in the animation module the reaction of this analytic model to loading in beams and in slabs. So that's all. After that, we use WinGraph as a standard module for viewing results. We can view anything we like. We can go to any results at any level. And that's a very interesting picture. Left, you see unbonded tendons and bonded tendons on the right. And you can see how it all distributes. And now, drawings in Revit. I already mentioned that we use our single platform for drawing generation. And now we are laying out the reinforcement. And after that, we simply plot the drawings. Despite this process is very complicated, we were able to automate this process and to set up our own systems and materials and set up export and prepare flexible families for our practical use cases, because we use it not only for graphical reasons but also for analysis, for calculations, and we continue improving our skills and develop collaboration tools that are provided in SOFiSTiK. So nothing special in this part of the video. It's just what happens in Revit. And as a conclusion, advantages of pre-tension calculations in SOFiSTiK. You can calculate reinforced concrete elements with tensioning and pre-tensioning, post-tensioning. You can calculate external pre-stress systems, bonded and unbonded systems, to consider losses, time effects, and consider secondary reactions and moments. It's just an excellent functionality. Use parameterization, and you can set up the software via text editor and calculate geometric parameters and volumes. It's important for detailed drawings. Thank you very much. And if you have questions, I'm ready to provide answers. An excellent presentation and on time again. So, do you have any questions to Igor? Yes, there are some, please. I'm Piotr Ivanilov, Neo Project. Can you go back to the slide with the slab, 3D slab, with columns, the very first view? With the video? Yeah, there was video, and it looks like solid modeling. Is it solid modeling? Yes, it is. So you can set beam elements with certain pretension parameters. Is it possible, or you don't use these options? It's easy, actually. Maybe it looks like it's. I mean, the word finite element, finite element. Oh, it was visualization. You can set the visualization you need, transparency or solid structure or finite element. Okay, thank you. I got it. Another question, please. Say your name and give your question. Sergey Goloskov, MOS Project 3. Pretension reinforcement in curved elements. For instance, we have a curved highway, and pretensioned reinforcement are in the same plane, but they are curved, and we use axes and in order to set up the geometry of those reinforcement elements, we need too many points. But is it possible to set to set some restricted parameters, and all the other, and the plane, the coordinates can be selected automatically? If you can use a text editor, you can use axes and curves, and you can use them. But in terms of plane views, we implemented such reinforcement layout that forces you to set special points. But it's simply because it's suitable to our needs. But this family is being developed further, so maybe we can implement that. It's not complicated, I think, to find a solution to your problem. And when we calculate the geometry, we do not set these points. We use text editor to transfer them. So it's possible to import a curve into the software and set the path of the reinforcement. And can we discuss details later with you or with whom? You can see my contact details here. And as far as I understand, the conference materials and business cards will be there. Yes, the website will be accessible to participants of the conference, and you can review the results and contact the speakers. You can use the lunch break for networking purposes, and you can have a meal and ask your questions. Yes, I already mentioned it. There are people with red badges around, and you can ask questions to those experts. Now, I have a very brief question to you. Igor, is it possible? Can you tell us if, let's imagine a customer wants to build a house for 100 apartments. How much time is needed to prepare all design and detailed drawings and documentation? Well, I'm not the right person to answer these questions. Okay, in this case, we take a lunch break, and please be back on time.